Okay, part B, it says show that x minus 2 is a factor of x cubed plus 9x squared plus 8x minus 60. Okay, so we've got a different cubic now, and we've got to show that it is a factor. Now remember, if it is a factor of it, right, we can factorize this, okay, and then, you know, if we put it equals to 0, okay, then we could say x minus 2 is equal to 0, all right, which means then, of course, x would equal to 2. In here would satisfy, this would come out as 0. Okay, so if we put 2 in here, 2 cubed plus 9 times 2 squared plus 8 times 2 minus 60. If that comes out as 0, we've shown then that actually x minus 2 is a factor. So I checked on my calculator. Okay. And I get out 0 indeed. So I can say, look, the remainder is 0. Therefore, x minus 2 is a factor. Now, going on to part 2, this is hence factorize it. If x minus 2 is a factor, we can, right, write this cubic here as a list of potentially three brackets, yeah? Okay? 3 brackets times together. That's what you usually get with a cubic. Okay, whereas with a quadratic you get 2 brackets. With a cubic you get 3 brackets. Okay, so x minus 2 we know is one of them because we know x minus 2 is a factor. It's already been established in part 1. We're going to have 2 other brackets. Okay, we can have 2 other brackets. Trouble is I don't know what those 2 other brackets are. Okay, I don't know what they are. But you need to remember, if you did have 2 brackets here, okay, the 2 brackets which we don't know, if I was to multiply out 2 brackets, okay, I'd end up having a quadratic, wouldn't I? Okay, so the 2 brackets here, I don't know what they are. Multiplying them out, I'd end up having a quadratic, which would be of the form ax squared plus bx plus c, yeah? But the good thing is, I know it's going to be x squared. It's, you know, I know the number in front of the x squared is going to be 1, okay? Because when I multiply this out, I would have x cubed, which is what I've got over here, yeah? Okay, so I don't need to write a there. I know straight away it's just going to be x squared. Trouble is, I don't know what, you know, with the 2 brackets multiplied, I don't know what I'd have, something x plus a constant, so I'm going to put plus bx plus c, right? I don't know what that b is, I don't know what that c is. So the next step then is to expand all this, right? So we can expand it all, okay, in terms of b and c, see what we get. So to expand it all, what I do is I focus on the x to start with, okay, and I do x times x squared, which is x cubed, x times bx, which is bx squared, okay, and then x times c, which is cx, okay. So you notice there I've times everything in this bracket by the first term in there, by the x. Now I'll move on to the second term, which is minus 2, and I'll times everything in here now by the minus 2. So minus 2 times x squared is minus 2x squared. Minus 2 times bx is minus 2bx. And minus 2 times c is minus 2c. Okay? Alright, so lots of things going on here, lots of letters. Don't be put off by it though. What you need to do now, be careful now, right, is to group all of the powers of x. So we start off with the x cubed. There's just a single x cubed. That's easy enough. Now we go with the x squared. So we have to be careful with the x squared. You've got a bx squared here and a minus 2x squared here. Now ideally I'd like to sort of put them together, okay? But the trouble is I can't work that out, can I? You know, I'd have b in front of that x squared and a minus 2 there. I just can't put them together as such. You know, if that was a number there, say that was 8, I could say, couldn't I, 8x squared take away 2x squared is 6x squared, because I could do 8 take away 2. But in this case, this is b. So I'd have to do b take away 2. So what I do is I put in a bracket, right? Put a plus there, and b take away 2 in the bracket, and x squared then on the outside. And then with the cx here and the minus 2bx here, let's put that together. So again, I can't take them away. So I just do c take away 2b x, and at the end then I get minus 2c. Okay, and then what I'll do then, I'll rewrite what I've got here, what it's actually equal to. And now we've practically almost there, right? We've done all the hard work. What you need to realize is these sides are equal, right? They're identical, okay? So that x cubed is the same as that x cubed, which is great. In front of the x squared then, I got a 9, haven't I? Okay? In front of the x squared here, I've got this, b minus 2, but they're meant to be equal. They've got to be equal. So basically, the 9 in front of the x squared is equal to what's in front of the x squared here, which is b minus 2. Okay? So what I've done is, right, I've equated the x squareds, right, or the coefficients of the x squared, speaking posh there, right? Basically, whatever's in front of the x squared, I said that they've got to be equal. So sometimes it's good to write that there to show we're focusing on that x squared. So in front of the x squared there, you've got a 9. In front of the x squared here, you've got b minus 2. All right? So if 9 equals b minus 2, we can then just take the 2 over the other side, can't we? The minus 2 over becomes a plus 2, and we get b. So b is equal to 11. We could do the same with x's. We could equate the x's, but you know what? There's no need to actually do it with the x's. We can ignore the x's, okay? Because all I need to do is find c, and to find c, I can just look at what I've got at the end here, the constants. So if I equate the constants, I got a minus 60 here, yeah? That's the constants. What do I mean by constants? Just a number, yeah? No x's involved. So minus 60 here, and the constants there is minus 2c. Okay, so minus 60 on this side, minus 2c this side. And then you've got a simple equation. Take the minus 2 over, of course, because you times in there. When you take it over, you'll be dividing. So that implies then that we get you to be 30. So what we can do now is we can rewrite that top equivalence, what we've got up here, to say x minus 2 and x squared. Now b we worked out to be 11. And c we worked out to be 30. And then we've got a quadratic which we can actually factorize quite nicely. So this will become 2 brackets. You just need to think of 2 numbers that multiply to give 30, and of course add up to give 11. And that's quite nicely because they're both going to be close together. They actually be 5 and 6. They times to give 30, add up to 11. And now you factorize this, okay? And we've got to a solution.